If anyone else has a sample exam you'd like to hand in, please do it. All right. This is going to be a short lecture because it's such an easy exam, right? Right. Just like next week will be a short time because that's also an easy exam. Oops, how did I get here? All right, so here's our sample exam. Before we get started, are there any questions? We'll go over, well, I fixed this and it seems to be a little bit hyperactive. All right, exam is next Monday, right here. Please be here. I will provide a periodic table. Make sure you have a calculator. Again, there should be some over there. I'll bring them out. I hid them, so hopefully they'll be there. As soon as we finish today, I will put quiz 1 up online. Remember, quiz 1 and the tutorials have to be done by 11 o'clock on Monday. Wednesday, there's no class. That's because it's Lab 5, which is a nomenclature worksheet. This is designed to help you with the exam. Please print it from Blackboard, do it, hand it in before the exam, and we'll get going. Everybody good? All right, our first question, simple mass conversions. We have 5.5 grams in our sample. Express that in milligrams. Our given value is our 5 grams. We need a ratio relating grams and milligrams. And then our ratio grams must be in the denominator. So something like this ought to work well. 1,000 milligrams in every gram. Start off with our given. Insert our ratio. Grams will cancel. Very simple problem. 5.5 times 10 to the third by George. There it is. I'm sure everybody wonders where I get my exam questions for this exam, the one that's coming up. It's very simple, really. For this one, I just go to metric convergence, hit new problem till I get one that I like. Again, this is grams to milligrams, basically multiplied by 1,000, 482. All right, simple table. Again, just like the tutorial. We need protons, charged neutrons for magnesium. We start off by trying to find magnesium on the periodic table, and there it is. All right, the atomic number is 12. Remember, the atomic number is the number of protons. Now, for the charge, we have 10 electrons, that's given. We just said we have 12 protons. So that's 10 negatives, 12 positives. You have 2 extra positives. The charge is +2. And finally, we want the number of neutrons. Our mass number is the sum of protons and neutrons. We have 12, this is 24, this is 12. Any problems with this? For lead, lead is down here at the bottom. Atomic number is 82. That means 82 protons. Now we're given that we have 125 neutrons. Remember, the mass number is the sum of 125 and 82, 207, I believe. We are given that the charge is plus 3. This is lead 3. If we have 82 positives, in order to wind up with 3 excess positives, we must have fewer than 82, in fact, 79 negatives. 79 minus 82 is our plus 3. Any questions? Once again, this came straight from the tutorial. We said 82 protons. Our charge here would be plus 3 because we have 79, and I believe 125 neutrons. Everyone good? Ammonium hydrogen carbonate. All right, we remember ammonium because ammonium is our only cationic polyatomic. It has 1 nitrogen, 4 hydrogens, and a plus charge. Carbonate, parent of the carbon family, has a -2 charge, and it's CO3. Now, the carbon is in the middle. We have 3 oxygens around it and 2 negative charges. When we have excess negative charges like this, we can put a hydrogen on one of the negative oxygens. When we do that, this is hydrogen carbonate, also called bicarbonate. To show this in our formula, we simply take and insert the hydrogen here and ditch our charges. Ammonium, plus 1. Carbonate, -2. We brought the hydrogen in, it comes in as a plus 1, and so we are neutral. Number 5, Willis. Again, these all come from here. Cesium phosphate. Cesium is here, group 1 metal. Phosphate, we know, is a -3. This will be plus 1. We need 3 of them. CS3PO4. All right, we're looking for an atomic symbol of an anionic element with 18 electrons, 16 neutrons, and a charge of -2. The problem here is, you say to yourself, what's the element? Well, the trick is, this is an anionic element. That means it has a negative charge. That charge is -2. This means it has 2 more protons, or 2 more electrons than it does protons. So, if it has 18 electrons, that's 2 too many. Must have 16 protons, and that makes it sulfur. All right, with our S. Now we remember when we do an atomic symbol, the number of protons is our subscript in front. The mass number is the sum of protons plus neutrons. That's our superscript in front. If our element is charged, we show the charge as a superscript after the symbol, like that. Sulfur 32. Any questions? All right, a table. It's a density problem. We have a tutorial for this. We are missing mass, but we know volume and we know the density. Remember, you get your 3x5 card, right? And if you happen to forget, density is mass divided by volume. You can write it in the corner. Small. All right. If density is mass divided by volume, then mass is going to be density multiplied by volume. So all we have to do is take our density, our volume, multiply them together. When we do, oh, there it is, 9.84. Any questions, guys? Here's our density tutorial. Again, we have a mass here, we have a volume, we need the density. We remember, of course, that density is simply mass divided by volume. Turns out to be about 1.2. This is where I get these problems for the exams. So tutorials are a great way to prepare. Which of these is wrong? Phosphate, PO4 minus 3. Yeah, that actually looks right. Phosphate is a minus 3. Phosphite, one oxygen less, is still a minus 3. Remember, we can have hydrogen phosphate and dihydrogen phosphate as well. Let's skip B. Aluminum. Aluminum is here in group 3. Because it's in group 3, it will be a +3 ion. That looks about right. Oxide. Oxygen is in group 6. That means it will pick up 2 electrons. It will be a -2. O, 2 minus, oxide. That works. Nitrate. Nitrate is the parent of the nitrogen family. If we take one oxygen off, we get nitrite. They all have a -1 charge. So that's right. The one that isn't right, of course, is B, persulfate. Remember, sulfate is SO2 with the -2 charge, SO4 with a -2 charge. Sulfite is SO3. They all have the same charge. Persulfate would have one more oxygen and would be SO5 with a -2, not a -4. Everyone good with this? Significant figures, how simple. We look at the number. First of all, does it have a decimal point? Absolutely, right there. Has a decimal point. That tells us that trailing zeros are real, but leading zeros are not. So everything in front of our first real digit goes. Everything after the first real digit stays. That's a pure. Everyone says, yes, I understand that, but I'll tell you the truth, on the lab where you had to write down significant figures for 0.0008. Almost everybody got it wrong. Yeah. So anyway, make sure you know leading go, trailing stay.
What about the 8 on the last one? What about
Yeah.
the 8?
Oh, the 8's the real digit.
Okay.
So that's 1, 2, 3, 4 real significant figures. All right, we have C4H8. It weighs 56 grams per mole. We're looking for the mass percentage of hydrogen. Hydrogen basically weighs 1. What we're going to do here is start off with the mole ratio. Then we're going to convert it to a mass ratio by multiplying by the stoichiometric coefficient and the molar mass. Going to multiply that fraction by 100 to get our percentage. So there's our mole ratio. We have 8 hydrogens in every C4H8. Okay? Now saying 8 moles of hydrogen is the same thing as saying 8 times 1.008 grams of hydrogen. 8 times 1.008 grams per mole. We're going to divide that by the molar mass of C4H8, 56 grams per mole. Multiply this out, that's 8 divided by 56. That's the number we get on our calculator. Now, we look at our problem. We are dealing with 4 significant figures in both of these, so we're looking to round this to 4 significant figures. First, we multiply it by 100. Round this to 1437. 1437. That's our number. Mole ratio, mass ratio, take the, do the math, multiply by 100, round to 4 significant figures. Everyone good?
Mine says 14.4.
The what?
On our practice exam, it says 14.4.
Oh, it does? Yeah, well. Yes. Yeah, I'm not sure what version of the exam is posted, but this one's right. You know that. All right. Again, this comes straight from the tutorial composition by mass. Lead. What is this called? It's not lead. Pd. Palladium. It's a transition metal. It's a halogen. There are 2 of them. That's a -2. This is palladium-2 bromide. Okay. And it weighs 266. To get the mass percent of palladium, there's 1 per mole. Therefore, simply 106 divided by that. For bromine, there are 2 of them. Multiply 79.9 by 2. Divide by 266, and we get about 60. Practice the tutorials. Scientific notation. Everyone loves this one because it's so easy. We're going to take this number with a whole bunch of zeros and a 1 and a 3. It has a decimal point. We're going to convert this to scientific notation. Now to do that, we're going to move our decimal point from here all the way over to between the 1 and the 3. All right. To do that, we had to go 7 places. We're going to the right, so the exponent is negative, 10 to the minus 7. Now remember, when we write something in scientific notation, all of the significant figures are in the coefficient. All of them. So the second part of this question is how many significant figures? Remember, leading zeros don't count, so it's just the 2. We're looking here at 1.3 times 10 to the minus 7. And of course, this comes straight from scientific notation. Here our coefficient is going to be 5.2. And to do that, we came over 6 spots to the left, so it's a minus 6. Electron configuration for carbon. Well, carbon is in the second period, and it lives right there. Now remember, that means that the first period is full. So this is the 1s orbital, and it has 2 electrons. Yeah, well, they all do. Okay. Over here, second period, the first 2 electrons go in the 2s orbital. So we're going to have 2s2, and that's 4 of them. So we eliminated 1. Our next 2 electrons are going to go into the p orbital. This is 1, 2. That's a 2p2. Now we have 2 choices. The problem with this guy is that it has 3s and 3p's. Nope. Second period, not third. So these go. This is our correct answer. 1s2, 2s2, 2p2. And again, we could do neon just sitting here thinking about it. It's all the way over here, second period, right? 2 electrons here, 2 in this one. We have 2, 2, and 2. And because it's in the second period, we have nothing in the third. Remember, on Blackboard, you have to put zeros. With this, you don't, but Blackboard, you have to put all those zeros. We have a sample of gas with 1.88 times 10 to the minus 9 moles in it. In the space below here, calculate the number of particles of the gas that represents. Whenever you see a particle problem like this, we're dealing with Avogadro's number. Remember, there are 6 times 10 to the 23rd particles in 1 mole. Here we have 10 to the minus 9 moles. All we have to do is use this as our ratio. This is our given. There's our given. We want particles per mole. That way our moles cancel. And then you take your friendly calculator, multiply 1.88 times 10 to the minus 9 by 6 times 10 to the 23rd. You should get 1.13 times 10 to the 15. Now, sometimes a problem like this, you are required to show the calculation. Sometimes you just write the number in a blank. If it says show the calculation, by George, show it. Any question? Physical changes. They're always accompanied by a change in state. a general rule in life. If something says always, it's always wrong. Change of state might occur, but it's not required. Physical changes result in the formation of homogeneous mixtures. Oh my goodness, not new compounds. Well, they don't make new compounds, but heterogeneous mixture as a solution. We don't have to dissolve something for a physical change. We can, but we don't have to. Physical changes always produce new elements, so that would be fun. Take lead and pound it into gold. No. Radioactive decay, that's chapter 11, is the only thing that makes new elements. So we've ruled out A, B, and C, and D. This is the dreaded none of the above. All right, on your little card, you have formulas written, things that you want to remember. What are the things you might want to remember? Mass divided by molar mass is moles, okay? So we're dealing here with perturbations in this equation. Molar mass divided by mass is moles? No, other way around. It's upside down. That's wrong. Molar mass times mass is moles. No. Molar mass times mass would be something else. Not moles. That's wrong. Oh, it's mass. Mass divided by moles is molar mass. Well, shoot. Simply going to swap those two. That'll work. This is our definition of a mole. Mass divided by moles, molar mass. All right. Nomenclature. Remember, you need to do lab 5, hand it in before the exam next Monday. Lab 5 is just a whole bunch of problems in nomenclature for review. We're looking for P2O5. First thing, phosphorus is here. It's a nonmetal. Oxygen is also a nonmetal. That means this is a molecular compound. With molecular compounds, we use multipliers. Okay. We have 2 phosphorus, we call that a di. We have 5 oxygens, we call that a pent. So I'm looking for diphosphorus pent oxide. There it is. And of course, there are several tutorials for naming, as well as lab 5. P2O5, well, we just did that. Determine if it's molecular or not. If it is molecular, put in your multipliers, and that's it. Any questions? George, we're all the way up to 16. Complete the following table. We're given a mass, a molar mass, and we want to know moles. I think we just did that. What do we remember? Mass divided by molar mass is moles. Simple as it can be. Take our mass, divide by our molar mass. This is 0.921 moles. On the exam, this will probably be in a table, just like this. Oh, a table just like this. This one, we're given molar mass and mass. We need moles. We remember Mass divided by molar mass simply gives us moles. All right. Here we go. Lewis structure for CO2. Now on the exam, you will get to draw a Lewis structure. That's exciting, isn't it? We know that there are two ways to do it. Kind of the random way that I do, and it by a set of rules. So let's do it the random way first. First, we have to find carbon and oxygen. There's carbon, there's oxygen. So this is group 4. We have 4 electrons, 4 valence electrons. This is group 6. We have 6 valence electrons. Start off with our carbon. Now we have 2 oxygens, each with 6 electrons, and I do it like that. Now, each oxygen has 2, 4, 6, 7. The carbon is 2, 4, 6. None of those are 8, are they? We want 8. To make 8, we're going to have to move some electrons in and make a double bond. Move that here in like that. And we can do the same thing with these two. Change them to our dashes. Now each oxygen has 8, 2, 4, 6, 8, and the carbon in the middle is happy because it has 8 as well. So that's the random way to do it, the way I do it. Let's do it again by the rules. CO2. First rule, count valence electrons, no hydrogens. Again, carbon and oxygen. We have 6, and here we have, we have 4. Here we have 2 times 6, that's 12. 16 electrons, no hydrogens. That's rule 1. Rule 2. Attach the atoms, that's the oxygen, to the central atom, that's the carbon, and give them all an octet. So all refers to the attached atoms. So we're doing this. All right, the next rule. See, each oxygen has 8 now. The next rule simply says place any remaining electrons on the central atom. Well, by George, we don't have any left over. We've used all 16. So we go to our last rule. Make double or triple bonds to give the carbon an octet. We do that this way. Move one of these guys in. Move one of these guys in. And here we are. Do it any way you want. Any questions? All right, number 18. Another nomenclature, K2O. Everyone knows K is potassium. On one exam one year, I gave a problem that was very much like this, except it was P2O. But I used the same sets of answers. You won't believe how many people got it wrong. But anyway, potassium is a K. First of all, potassium, group 1 metal. So it's ionic. We don't use multipliers. So we're just going to say we have a potassium and an oxide. Don't use multipliers, potassium, and an oxygen. Again, the tutorial, cesium, group 1 metal, ionic compound, simply cesium and selenium. right, which of these guys will the cation have a +3 charge? Well, we can do that. Calcium. Calcium is a group 2 metal. Because it's group 2, it will have a +2 charge. Magnesium oxide. Magnesium. By the words, there it is. It's also a group 2 metal. It's +2. Ammonium carbonate. Well, we've seen ammonium already in this exam, haven't we? We know this is a polyatomic ion, and it's a +1. So no. Aluminum sulfide. Aluminum is a group 3 element. Because of that, it's a +3 charge. Now how about the last one, phosphorus trichloride? Phosphorus, chlorine, they're both nonmetals. This is a molecular compound. It doesn't have anything it's charged. Number 20. How many moles is 42 grams of copper? Copper has a molar mass of 63. Once again, we remember mass divided by molar mass is moles. Here's our mass. Here's our molar mass. Simply divide them. Oops. This jump. 0.67 moles. Remember, 0.67 is different than 0.670. We are dealing with 4 significant figures here and 3 here. So we need 3 in our answer. Now, when I wrote this sample exam, I did not mean to write this as the extra credit. Okay? I just screwed up. But I did it anyway. How many moles is 83 grams of cadmium? Same problem we just did. Again, mass divided by molar mass. Here's our mass, here's our molar mass. The extra credit, you always show your work. So here we have mass divided by molar mass is moles, and we get 0.75 moles. Your exam will have, just like this one, 20 questions and a 5-point extra credit. You will not get the same 2 questions in a row though. Sorry. Again, this is straight from the tutorial. Here's a mass, here's a molar mass, and we get moles. All right, I told you to be short. Again, the exam is Monday. Everyone gets a periodic table. Make sure you have a calculator. Tutorials and the quiz must be completed by that time. Also, no class Wednesday. New Lab 5, which is online nomenclature worksheet, handed in on Monday before the exam. Here's our tutorial list. Remember, you get up to 5 points for each of these. That's a lot of points. Please do the tutorials. Any questions, guys? If you did not hand in your sample exam, please do it now.
Yes, one sheet is supposed to be. Can I take a photo just to see?
What's your name?
Eileen, A-Y-L.
There you are.
Thank you. I just have a question. Can we bring our own periodic table, or will we use someone?
No, you should use mine because some people have periodic tables that have all the answers.
Oh,
Thank you.
thank you.
Also, I did do some of the tutorials like last week, so I didn't know if you saw them or not because I did the email thing for the tutorial, but I don't know if you saw them.
Do you only get credit on Blackboard?
Gotcha.
So make sure you do Blackboard. Thank
I
you.
was just wondering, for the one of the tutorials you got that you had here, it said that, how do you, like, I don't know what's it called. It's on the sample exam, can I, like,
Sure.
it was for